Hey guys, what's going on here? Today we're going to have a little statistic extravaganza. I'm going to pick some random problems from page 444 through 449. Uh, so let's go ahead and begin. Let me go ahead and pull up our problems here. Let's look at problem one. A city ballot includes a local initiative that would legalize gambling. The issue is hotly contested, and two groups decide to conduct polls to predict the outcome. The local newspaper finds that 53% of 1,200 randomly selected voters plan to vote yes, while a college statistics class finds 54% of 450 randomly selected voters in support. Both groups will create 95% confidence intervals. Now, at any point in time in the video, I would encourage you to stop and try to work these out on your own, and then press play, continue the video, see how you do. So with that being said, let's go ahead and answer these three parts here. Question A, without finding the confidence intervals, explain which one will have the larger margin of error. Well, this one's kind of basic. The true answer would really be the class's interval will be larger because their sample size is actually smaller. So if you look right here, their sample size is 450. That's going to create a larger margin of error as opposed to this larger sample size. It's going to have a smaller margin of error. So I think something just happened and I didn't mean it to happen. Alrighty, let me close out of this. So question A, we're going to say the class because their sample size is smaller. Alright. So now we can find both confidence intervals. We got to find the confidence intervals for the local newspaper and the statistics class, which I will have to go separate here, and we'll go through the mathematical steps. So let's bring back up Dosher here. We'll go to page 2, and we'll start off with the newspaper. So just so that I'm nice and neat here, my confidence interval, I like to write it down. It's 95%. The sample size was 1,200. And my p hat will be 53%. Now remember to change this to a decimal. Okay. Alright, so with that being said, with the confidence interval of 95%, that means we're going to go 2 standard deviations within the mean. So we'll have p hat plus or minus 2 times our standard error. Alright. Next thing we got to do is go ahead and calculate the standard error, which is using this formula, square root of p hat times 1 minus p hat divided by n. So right in here we'll have 0.53 times 0.47. I got a little bit bigger there. And our sample size was 1200. Now, I think if you remember from a previous video that I did, I like to go ahead and calculate this first, but I just do one little thing at a time. Just do an order of operations here algebraically. So we'll do 0.53 times 0.47. Hit enter. Let's go ahead and divide that by 1200. Hit enter again. Remember what we talked about with scientific notation. We got to remember to square root at this point, which is still to this day. I worked out one problem. I forgot to square root it. Let's not do that here. So we're going to make sure we square root this number. We got to put it in standard form. So we're going to go 0.0002. I think that'll be good enough. And we get 0.0141. That's going to be our standard error. So I'm going to write that down. 0.0141. Let's minimize the calculator here. So now I got the standard error here. Everything's in place, ready to plug and chug. So I'll pick a different color here so we can see our steps. We got 0.53 plus or minus 2 parentheses 0.0141. Now we can build our confidence interval for the newspaper. I'll just put them up here. It's supposed to be a parenthesis. I'll just try it again. Alright, so let's go back to the calculator and punch this in here. We'll go 0.53 plus 2 parentheses 0.0141, and we'll close parentheses, hit enter. So we get 0.5582, which is basically 55.8%. Okay, so I'll write that up above here. So I'm halfway there. This is what we got so far. Now we got a minus. So remember that little trick? Second, enter. Change the plus to a minus. And there we go. Hit enter again. We got 0.5018, which is 50.1%. Gosh. So 50.1, 50.2% if we round correctly. So I'll just write that as 50.2%. So right here, we have our confidence interval. We're 95% confident. We got our percentage interval for the newspaper. Now we got to do the statistics class. Same confidence interval, different sample size. So I'm going to go back to a different color. So I like to write everything to the side here, that way I know what I'm looking at. My sample size is smaller, 450. And my p-hat this time, if we remember, going back to the problem, okay, this is the p-hat for the statistics class, which is 54%. We got to change that to a decimal. So it's going to end up being 0.54. That's what I'm going to use in the end. So I'll set this up. p hat plus or minus. We're a 95% confidence interval. So 2 standard deviations within the mean, and we need our standard error. Okay, so we'll go back to the square root of p hat times 1 minus p hat divided by n. So I'm going to get a little fancy with the collars here. So square root 0.54 times 0.46. 1 minus p hat, that's 0.46. Then over 450. Now we can find our standard error. Let's bring back the old faithful here. We'll scoot him in the middle here. So punch it in. We'll go 0.54, do the top first, times 0.46. Okay, hit enter. Okay, we got to divide by our n. The last thing you have to do when you're finding standard error is square root. Can't forget that. Now this number will be in scientific notation. Okay, so make sure everything looks good. Now I'm going to square root that. So I need to go second x2 point, put this in standard form, and hit enter. So we got 0.02, I'm having a hard time saying 0.0223. So I'll write that as my standard error. 0.02 to technically be 4. Alright. So now we can plug all this information. 0.54 plus or minus 2 times our standard error. Okay, everything looks good, I hope. Alright, now let's find our confidence interval for the class. Go back to the calculator. Just run the calculations real quick. 0.54 plus 2. This is really the hard part. Punch it in on the calculator. So I get a 58.5 percent. I'll write it as a decimal first. Then I'll just go 58.5%. Okay, let's go ahead and hit second entry, or second enter, and change that to minus. That way we build our interval. So we got 0.4952. And that's roughly 49.5%. So there's our two confidence intervals for both the newspaper. It's right here. Okay, and here's our class, their interval. Now the last part of this question, that's not what I wanted. Last part of the question is, which group concludes that the outcome is too close to call, and why? There's several whys, I suppose, but one that I find is, which group concludes that it's too close to call? It's got to be the students, because 50% is within the interval they calculate. So they're going to end up saying, well, this is way too close to call. The newspaper eh, they're leaning toward a different direction. So that's just one way of looking at it. Let's go ahead and scroll down to problem 2. I'm going to go ahead and click on the next page on Doser here. Problem 2. Wildlife biologists inspect 153 deer taken by hunters and find 32 of them carrying ticks that test positive for Lyme disease. That's not a yummy situation. Part A. Create a 90% confidence interval for the percentage of deer that may carry such ticks. Part B says if the scientists want to cut the margin of error in half, how many deer must they inspect? So we're going to look for a new sample size. And then part C asks, what concerns do you have about this sample? And I'm going to assume that it is from part B. So let's build this 90% confidence interval for part A here. So I'm going to scroll down and list everything I know. So we're looking at part A for problem 2. So I'll just go ahead and write problem 2, part A. Okay, we're building a 90% confidence interval. So I'm going to write CI 90%. Sample size 153 deer. Okay, I'll click back on that. Have you look at it. So there's our sample size. It really didn't give us a p-hat. It's kind of hidden. All you really have to do to find p-hat is, well, how many did they find have ticks? Well, 32 out of the 153. Well, that equals 20.9%, which is a decimal. If you just divide, I had this little rule back in the junior high days. This little line of mine, it tells me divide. 0.209 is my p-hat. So now I can go ahead and set up my confidence interval. Now with this being 90%, okay, you almost have to use Z-star. So if you got p-hat plus or minus a critical value, okay, times the standard error, alright, now we can build upon that. Let me change colors here. So what we'll do, guys, is just plug and chug. Gee, I wonder when you've heard that before. Z critical for 90% confidence interval, 1.645. Okay, now we got to calculate that standard error. Now I could go ahead and plug it in, but I'm going to go to the side somewhere and get it out of the way. Remember, it's p-hat, which is 0.209. You could almost call this q-hat, 1 minus p-hat, 0.791, divided by our sample size. And when calculated, guys, just to kind of save up on time, we're going to get 0.0316. You can check it, make sure. I'm pretty positive it's right. So let's go ahead and build our intervals here. We'll go ahead and punch this in 0.209. I'll use the calculator right here. 0.209 plus, okay, I like to use parentheses here, 1.645. Anytime you're using a Z critical, 0.7, no, what am I talking about? 0.0316. Let's hit enter. Okay, I get 26.1 basically. So I'll write that as 26.1%. Now let's go ahead and second enter. Change the plus to a minus. Trying to. Hit enter. We get 0.157, which is 15.7%. Alright. So that's part A. Pretty much that's it in a nutshell. So now, let me minimize this. We got to find part B. This one is probably the hardest part of all this. Part B, if the scientists want to cut the margin of error in half, how many deer must they inspect? The margin of error, how do we find that? Okay, well, I'm trying to show you. Margin of error equals Z critical times the standard error, which is basically this. All divided by n. So they're wanting to know what their sample size is if they cut the margin of error in half. So at the end of all this, when we find our margin of error, we're going to have to divide it by 2. I'm going to go ahead and just plug and chug here. Yeah, I mean, that's just a little curveball for us to solve. I'll just go through here and go ahead and fill in the blanks. This is going to be divided by 153. In the end, guys, the margin of error is going to end up being 0.052. Now they're wanting to cut this in half. Alright, so going back to that question again, how many deer must they inspect if they cut the margin of error in half? Well, it was 153. Some people are going to say, oh, I'm going to put 306. Well, that's not the case. So let's divide this little margin of error by 2. And that will give us 0.026. Alright, so now there's our margin of error cut in half. Now what we got to do is find the sample size. Now, there's another little method of formula. N equals p hat times 1 minus p hat. And then I'm going to put brackets here. Our critical value divided by our margin of error. That section is going to be squared. Alright, so again, some algebra. Let's go ahead and plug and chug here. We'll have n equals 0.209 times 0.791. None of that really changed. Now we have our Z critical. We were talking about what, 90%? Okay, 90%. Our critical value for 90% is 1.645. Divide that by our margin of error, 0.026. That little piece is going to be squared. So I'm going to demonstrate this on the calculator, how I'd punch it in. That is not my calculator. I'm sorry, guys. Alright, so let's clear this malarkey off. So we got 1.645. Go ahead and divide that by the margin of error, 0.026. and hit enter. Whatever you get there, let's go ahead and square that. Alright, I just hit square. I'm taking my answer and I'm squaring it. Go Bucks. So that is just right here. Okay. Now what we got times that by 0.791 and 0.209. So let's pull the calculator back up. Let's just go ahead and hit times. Bring this answer down. Go 0.209 times 0.791 and hit enter. Okay, so roughly they're going to want to sample 600 and let's just round up here, 662 deer. That's going to be their sample size if they cut the margin of error in half. Let's look at the last question here. What concerns do you have about this sample? Well, a lot of concerns. This sample may not be as random as what people might think. You're talking about deer taken by hunters. Well, what about the deer that are left on the side of the road? Or, maybe they're not looking at the sex and the age of the deer. Maybe it's not representative enough. Just list any kind of concern. I think the most popular would be that the sample may not be random. So, question 2, get her done. Let's move right along here. I know this has been a long one here. Problem 3. During routine screening, a doctor notices that 22% of her adult patients show higher than normal levels of glucose in their blood, a possible warning signal of diabetes. Hearing this, some medical researchers decide to conduct a large-scale study hoping to estimate the proportion to within 4% with 98% confidence. How many randomly selected adults must they test? Well, good thing is, guys, this is like a one-step process, really. Okay, right here, we have a margin of error. There's our confidence interval, level of confidence, and here's p hat. So we got all three things just staring right at us. What we can use, what we can use is what we just used in the deer problem, finding a sample size. We're going to have the critical value. We got our margin of error. We got the p hat. This is basically, in this type of situation, plug and chug. So let's get to it here. N equals p hat 1 minus p hat. I like to write the formula down. Doesn't hurt. ME, margin of error. I call it margarine of error at one point. Yeah, I got made fun of. So let's stay on task here. P hat 0.22. 1 minus p hat 0.78. And then our critical value with the confidence level that we're at, 98% confidence. The critical value of that is going to be 2.33. After you start using these forever and ever, you just pretty much memorize it. Margin of error is 4%. Make that a decimal. So now we just punch it in, and we end up with somewhere around 582 randomly selected people. Alright, guys. I know it's been a long one. Until next time, rock and roll.